North America is home to some of the largest lakes on the planet. We have Lake Superior, Great Bear Lake, Lake Michigan, and hundreds of more massive lakes. But did you know that there was a lake in North America that covered an area larger than all of the Great Lakes combined? A body of water so enormous that when it finally drained, it plunged the entire northern hemisphere back into an ice age for over 1,000 years. This was glacial Lake Agassiz, and it existed right here in North America approximately 13,000 years ago. Today, the Red River Valley, Lake Winnipeg, and the surrounding lakes are pretty much all that remain of this prehistoric giant. But the story of Lake Agassiz is a story of how our continent was shaped, and how our climate was transformed, and how a single catastrophic drainage event may have given rise to the flood legends across multiple cultures. I'm going to take you on a journey back in time to explore the largest lake in North American history, a lake that truly should not be forgotten. And as always, this is Ali, and welcome back to Urban Atlas. Before we dive into the lake itself, we need to talk about the man it was named after, Louis Agassiz, a Swiss-American naturalist who, in the mid-1800s, revolutionized our understanding of Earth's history. Agassiz was one of the first scientists to propose that Earth had experienced ice ages, periods when massive glaciers covered much of the planet. In 1879, American geologist Warren Upham was studying the flat, fertile plains of Manitoba and the Red River Valley. He noticed something particular: beach ridges, wave-cut terraces, and sorted sediments hundreds of miles from any ocean. These weren't river deposits, they were lake deposits, and they were enormous. Upham realized that he was looking at the remnants of a massive glacial lake that had formed during the last ice age. He named it Lake Agassiz, honoring the scientist who had first proposed the ice age theory. What Upham discovered would reshape our understanding of North American geology and climatic history. To understand Lake Agassiz, you need to first visualize what North America looked like approximately 110 to 12,000 years ago. During this time, the Earth was in the grip of the last glacial maximum. Much of the northern portion of the North American continent was covered by the Laurentide ice sheet, which was a colossal dome of ice up to 3 kilometers thick, and it covered most of Canada and even into the United States. The Laurentide ice sheet reached its maximum extent approximately 20,000 years ago, and at this point, this ice sheet covered approximately 13 million square kilometers. Now imagine an ice mass so heavy that it actually depressed Earth's crust beneath it by hundreds of meters. The weight was incomprehensible, trillions upon trillions of tons of ice. And as global temperatures then began to warm around 16,000 years ago, this massive ice sheet started to retreat. But it didn't melt evenly. The southern margins melted faster than the interior, creating a crucial problem: where would all that meltwater go? Keep in mind that natural drainage routes would be rivers that normally flowed north into Hudson Bay, which is at a lower elevation. But these were still blocked by ice. Thus, the meltwater really had nowhere to go. It began to pool along the southern edge of the retreating ice sheet, trapped between the glacier to the north and east and the higher ground to the south and west. And this, my friends, was the birth of glacial Lake Agassiz, approximately 13,000 years ago. Because of the massive size of the Laurentide ice sheet, Lake Agassiz was also a giant. At its maximum extent, it covered approximately 440,000 square kilometers, an area larger than all of the modern Great Lakes combined, and roughly the size of the Black Sea today. Because the lake was dynamic in nature, its depth varied considerably across its extent. In some areas, particularly near the ice margin, it may have been over 210 meters deep. However, much of the lake was relatively shallow. It had spread across the flat prairie landscape that had been scoured smooth by earlier glacial advances. But here's what makes Lake Agassiz unique. It wasn't stable, it was an ever-changing lake. As the Laurentide ice sheet continued to retreat northward, the lake's boundaries constantly shifted. New outlets would open and then close as the ice re-advanced. The lake would drain partially or completely and then refill. It was dynamic, ever-changing. Researchers estimate that the lake lasted approximately 5,000 years. And because of this, the lake had multiple phases, each named by geologists studying different beach ridges and sediment deposits. There was the Lockhart phase, the Moorhead phase, and the Emerson phase, and many others. Each represents a different configuration, a different water level, and a different outlet. Modern remnants of this lake do remain. There's Lake Winnipeg, Lake Winnipegosis, Lake Manitoba, Lake of the Woods, and the Red River itself. But these are just tiny fragments of what was once a giant lake. The story of this ancient lake is really the story of its outlets, the routes through which this enormous volume of water actually escaped. You see, as the ice retreated, different drainage pathways opened and closed, fundamentally altering not just the lake, but the entire continent's hydrology. Initially, Lake Agassiz drained south through what's known as a River Warren outlet, near present-day Browns Valley in Minnesota. This glacial river carved what would become the Minnesota River Valley, a massive channel disproportionately large for today's modest Minnesota River. The river flowed south to the Mississippi River and ultimately into the Gulf of Mexico. Now, as the ice retreated further back, eastern outlets opened periodically, allowing water to flow through the Great Lakes Basin towards the North Atlantic Ocean via the St. Lawrence River. These drainage events were significant, but still relatively controlled. At various times throughout its life, the lake drained northwest through the Clearwater Athabasca Spillway into the Mackenzie River system, eventually reaching the Arctic Ocean. Now, researchers believe that the most dramatic changes occurred when outlets opened directly north into Hudson Bay. Now, this is where our story takes a turn from geological curiosity into a global climate event. You see, around 8,000 years ago, in what's called the final drainage event, the remaining Lake Agassiz catastrophically emptied into Hudson Bay. And this was not a gradual draining. This was a deluge. Estimates suggest that roughly 160,000 cubic kilometers of freshwater, almost half the volume of Lake Michigan, poured into the North Atlantic in a matter of months, possibly just weeks. So now we reach perhaps the most fascinating part of Lake Agassiz, its connection to a mysterious climate event called the Younger Dryas. See, approximately 12,000 years ago, the Northern Hemisphere was warming, emerging from the Ice Age. Then suddenly and dramatically, temperatures plunged. Europe and North America returned to near glacial conditions. This cold snap lasted approximately 1,200 years before temperatures abruptly warmed again, around 11,000 years ago. Now, what caused this climate whiplash? Many scientists believe Lake Agassiz was the culprit. Here's the theory. Around 12,900 years ago, a major drainage event from Lake Agassiz released an enormous pulse of freshwater into the North Atlantic Ocean. And this insane amount of freshwater influx disrupted the Atlantic meridional overturning circulation, an ocean conveyor belt that brings warm water north and cold water south. Keep in mind that the ocean's circulation system depends on differences in water density. Warm water flows north at the surface and cools near the Arctic. It becomes denser and sinks, flowing back south at depth. This circulation is crucial for moderating global climate, particularly for keeping Europe warm. But when Lake Agassiz dumped massive amounts of freshwater into the North Atlantic, it diluted the ocean's salinity. The water couldn't become dense enough to sink. The circulation slowed or perhaps even stopped. Without this heat pump, temperatures across the northern hemisphere ended up plummeting. The evidence for this scenario is compelling. Sediment cores from the Gulf of Mexico show a pulse of freshwater discharge from the northern Mississippi River exactly at this time. Now, it's important to note that not all scientists agree on every detail of this. Some argue for different drainage routes or timing, but Lake Agassiz's connection to the Younger Dryas remains one of the most elegant explanations for this climate mystery. There are, however, a host of other possible theories and explanations of what caused the Younger Dryas, and perhaps that's a topic we might explore in a future video. Now, despite the many drainage events of Lake Agassiz, it didn't disappear all at once. It persisted, advancing and retreating, filling and draining for thousands of years after the Younger Dryas. Like I mentioned previously, the lake's final major phase occurred around 8,400 years ago. As the Laurentide ice sheet made its final retreat from the Hudson Bay lowlands, the last natural dam holding Lake Agassiz gave way. The remaining lake, still enormous, though much smaller than its peak, catastrophically drained northward into Hudson Bay, and from there into the Atlantic and the Arctic Ocean. After this final drainage, Lake Agassiz was gone. What remained were much of its smaller descendants, Lake Winnipeg, approximately 24,000 square kilometers, but only a mere 5.6% of Agassiz's maximum size, along with many of the other lakes I mentioned previously. But the legacy of Lake Agassiz extends far beyond these remnant lakes. The enormous volume of freshwater it added to the world's oceans contributed to post-glacial sea level rise. The flat, fertile plains left behind, formed from lake bottom sediments, became some of North America's most productive agricultural land. And the Red River Valley, former lake bottom of Agassiz, is now one of the continent's premier farming regions. And if you know what to look for, you can still see Lake Agassiz written across the landscape. Perhaps most visible evidence are the raised beach ridges, ancient shorelines now stranded miles away from any water. These parallel ridges formed by wave action along the lake shores march across the prairie in nested sets, each representing different lake levels. And then of course, there's the remarkably flat landscape of the Red River Valley itself. The flatness is so extreme that the valley has been described as one of the flattest places on Earth, resulting from sediments settling on the lake bottom. Glacial Lake Agassiz was essentially a massive settling pond, creating perfectly level lake bottom deposits. And the story of Lake Agassiz isn't just geological, it's potentially human as well. The final drainage events of Lake Agassiz occurred within the period of human habitation in North America. And some researchers have speculated about the connections between catastrophic drainage events and flood myths found in indigenous cultures across North America. The Ojibwe, Cree, and other indigenous peoples of the Lake Agassiz region have oral traditions that speak of great floods and changing waters. While we must be cautious about directly connecting ancient geological events to oral traditions, the possibility that these catastrophic drainage events were witnessed and remembered is tantalizing. Archaeological evidence shows that Paleo-Indians inhabited the regions around Lake Agassiz during its existence, and these early inhabitants would have lived along the shores of this vast body of water, harvesting its resources. And when major drainage events occurred, the impact on these communities would have been profound, entire coastlines disappearing, and vast new lands emerging from beneath the water, and dramatic shifts in the landscape. The drainage of Lake Agassiz would also have opened new corridors for human migration. As the ice retreated and the lake drained, new routes across the continent became available, potentially facilitating the spread of human populations across North America. The story of Lake Agassiz continues to evolve as modern research and techniques reveal new details about this ancient giant. Recent studies using advanced computer modeling have created detailed simulations of Lake Agassiz's drainage events and their impact on ocean circulation. And these models help us understand not just what happened, but why it happened and what the consequences were. Geologists continue to map and date the various beach ridges and sediment deposits, refining our understanding of the lake's complex history. New dating techniques are providing increasingly precise timelines for drainage events and lake level changes. So this great lake existed for approximately 5,000 years, really a geological blink of an eye, yet long enough to have profoundly shaped North America and possibly influence global climate. This massive body of water was born from ice, constrained by ice, and ultimately destroyed by it. Its legacy surrounds us in the fertile farmlands of Manitoba and the Red River Valley and the lakes of central Canada. Lake Agassiz and similar glacial lakes remind us that our planet really is dynamic. The landscapes we think of as permanent are actually temporary, and that water, whether frozen in ice or flowing in floods, has the power to reshape continents and alter climate. So the next time you see a map of North America, imagine the vast expanse of blue covering the center of the continent. But the most insane part of this all is Lake Agassiz wasn't the only glacial lake in the center of North America. There may have been more. Glacial Lake McConnell, Glacial Lake Missoula. Perhaps those are lakes we may discuss in future videos. And as always, I'll catch you in the next one. Peace.